All right, everyone. Welcome to another episode of O365A. In this episode, we're going to be talking with Paul Andrew, who's a program manager in the M365 Enterprise and Cloud, and Jeff Mealiffe, who's also a program manager architect in the M365 networking team. And, given that we're all working from home and, there's also a plan to return to office, we felt it would be really good to talk to these gentlemen about, M365 networking and how that connects to the services from a business perspective and also from an end user perspective. So welcome, gentlemen. Thank you for coming on the show with us today. And Paul, why don't you start us off? Maybe tell us a little bit about yourself and your journey at Microsoft and what you do now.
Okay, great. Well, it's great to be here and talking with you all about network and connectivity. I've done a few different things at Microsoft over time. Worked in consulting and worked in product management. But for the last few years, I've been working on network connectivity and network performance that our customers have between their user locations and Office 365, and really focusing on what can people do in order to get the best performance possible for users related to their networking. Microsoft spends a huge amount of time and effort in improving the network connectivity that we have on our network. We have this huge global network which connects onto the internet at a large number of different locations. But key is getting from a user's PC out all the wires that are involved in getting to that network. And so I spent a bunch of time thinking about that. And we have two tools that we're working on, which of course we'll talk about today. One is connectivity.office.com, a standalone tool, and then also the M365 Admin Center. We have health network connectivity in there, a more integrated tool. Jeff, I'll hand over to you to introduce yourself.
All right, sounds good. My name is Jeff Mealiffe, and I'll echo Paul's comment. It's great to be here talking about networking and connectivity today. Certainly enjoy any chance we can get to get out there and talk about what's top of mind. I'm a 20-year Microsoft veteran. I've had a number of roles in engineering over the years, test development and program management. Primarily focused on Exchange. Spent many years working on performance of the Exchange product. And I'd say probably about a decade ago, I moved over to focusing on connectivity and very large enterprises from a kind of customer relationship perspective and managing problems. And we've had some problems in this space over the years, including trying to help people do the right thing with ExpressRoute and get their connectivity to our cloud services in a good position. I've been in the role that I'm in now for a little over a year, and my team is very much focused on operating a very large set of network infrastructure that delivers Microsoft 365 services to the world. We have a huge amount of network traffic, a very significant portion of the traffic on Microsoft's network and on the internet in general flows through our infrastructure, and we do a lot of cool stuff internally to keep it up and running and highly available and performant at all times. So yeah, it's a lot of fun.
Awesome. Thanks for that intro, and thanks again for joining us today. So I'll start things off, and I wanted to get into connectivity.office.com. The thing about this tool is it's a brilliant little site, but I find that a lot of my customers don't actually know about it. So I focus, and as do the colleagues on the call here, we do a lot of Teams implementations, and in part of doing those and delivering those engagements, we got to get these, make sure the customers' networks are up to speed and are they ready to actually deal with Teams and the variety of other services we need to run. So I'm amazed that they don't know about this great tool that runs like hundreds of different tests. So maybe just tell us a little bit about connectivity.office.com, why people should run it, why should users sign into the site, the benefits of signing in, just things in general about the tool.
Yeah, so of course, and this was the first testing tool that we built for testing connectivity between a user's location and Microsoft's network. We're, of course, continuing to support that, and we're doing work that shows up automatically in the admin center with our running tools now as well. But talking about connectivity.office.com, it has quite a wide variety of tests, but tests that are all aligned with identifying something that where there's a network issue or a network slowdown or something that we can detect, which is specifically going to impact the user's experience. So we're not looking for something that can't be detected by a user. Like if you make this change, users won't notice. We don't test those kinds of things. And so we have different tests for connectivity between Outlook and Exchange, between the OneDrive for Business Sync client or the Pro Plus applications and OneDrive or SharePoint backend, and then tests between the Teams client we use to connect into our Teams infrastructure. And so we've worked with each of those engineering teams. Jeff's on the Exchange team. We worked with them first to try and call out, look, what are the networking attributes that we need to look at and test, and what are the thresholds for those tests that would be worthy of alerting users that something is going on. So this tool was how we put these together. And one of the key things you find is location is really important, like how far away your user is from whatever that piece of networking equipment is. Networking is pretty fast, but at some point, distance makes a big difference. And sometimes you can be talking about thousands of miles of networking cable or fiber, and it really does make a difference. It also can make a difference in terms of if the distance or the location is not identified correctly, that could cause an Office client to pick some wrong configuration because it thinks it's in a different location. So we identify the locations of different networking components on a map that we show. And once we've run these tests, we actually show a comparison of your performance to other Office 365 customers in your same location, in your same city. So we have data from all Office 365 customers that we can compare you. And this is really interesting because, like, if I know that there's other people in the next building or in the same city that are somehow getting much better network connectivity than I am, I probably want to call up my network provider or maybe have a look in my garage at the network connectivity that I have down there and figure, why is that? Maybe some of our tests will tell you, maybe they won't, but we show that comparison. And then the other thing that we show when you run these tests is just all of the details of the specific tests that we actually ran and the results that we saw and how we compared those and whether they're past a threshold or not. You asked about signing in, Dino. It has a sign in there. You can run it anonymously if you are just trying to test a location and you want to see a result. You can do that. If you sign in, you can do a couple of things. One is the results will be shared with your administrator for the tenant, and that will show up in the admin center under Health Network Connectivity. The other thing is that this allows you to share the results with other people. So the sharing is lit up after you sign in. So you can share it with people in your tenant, or you can share it with a link after you sign in as well. So if you're working across a tenant, it's useful to do that sign in because it will just save it with the tenant with your data, and you can go back and look at the results later on.
I just tack on there actually two tiny additional thoughts. One of them, Paul mentioned this is the first tool that we've done of this kind. I think it's actually more significant than that. Each of the individual workloads over time has had various test tools that sort of did kind of what we're talking about here, but this is the first opportunity for us to really have kind of a one-stop shop to get feedback on your connectivity with guidance specific to each workload. The other is that this ties back to what we refer to as our principles of network connectivity, which you'll see show up in our documentation all over the place. We spent a great deal of time a few years ago trying to take all of these great ideas that we had in our head of the right way for our customers to think about connecting their infrastructure to our cloud services, and we came up with a very simple, straightforward set of 4 principles that are easy for an IT pro to understand, easy for an IT pro to explain to their business decision maker, who they're going to go to argue for for additional bandwidth or changes in their infrastructure. And all of the guidance that's coming out of this connectivity.office.com tool and the other tools that we're talking about tie back to those simple, straightforward rules. So highly encourage everyone listening to this to go take a look at the documentation around connectivity for the Office Cloud and really understand what those principles are.
Awesome, thank you.
Yeah, I have a couple just sort of logistical questions about the tool as it exists today. First of all, I love it, and what I really like, what Paul mentioned, is I can see what other people around me in my location are getting, and I think that's really valuable. Obviously, to do a test from the device, you're going to need to run something on the device, and the tool as it exists today, that takes the form of an exe that the user downloads and runs locally. So I've referred several people to this tool. For people who are a little more techie, they get it, they run it, they get the results. But for others, there's a couple of friction points. One is typically it requires .NET Core, which they have to go download and install. And then the other one is just security. People are really paranoid about running a .exe downloaded from any site, including Microsoft. So I don't know, Paul, if you just want to if you have any comments about that, or if there's going to be any changes to the tool going forward.
Yeah, so it's always a balance. We wanted to try and make sure that we run all of the tests that were needed to be able to give good advice. We do run some of those tests in JavaScript up front, and we get some data server side, but the majority of the tests that we run are client side, and they run in that executable. The executable does require Windows, and it does require .NET Core. You can actually go to the site from a phone or a Mac, but obviously we don't show the executable, so you just see the tests which are available from JavaScript. But it is always a balance. This tool is, I guess, primarily intended for someone who is either a network engineer or who is really digging into this issue of network connectivity. You want to see the test run right now, right in front of me. This tool runs the test one time. And if you're doing that, you're probably running it a few times. The executable that we download needs to be downloaded every time you run a test. We keep it as small as possible, and once the .NET Core is installed on a machine, you can go and run it on multiple machines, but it's certainly always a balance as to how you do that. The exe, of course, is signed by Microsoft, so I encourage people to check that out before they run executables. It is signed, which means that we use a certificate that Microsoft owns to prove identity and that hasn't been tampered with. So people should absolutely do that before they go ahead and run it. But yeah, it is a blocker for like an average end user to do that.
Yeah, good stuff. So one last question, and it's more it's something I'm really personally interested in, having spent a lot of time diagnosing Skype for Business network issues. Especially when you're dealing with real-time media. And I think this question is really important because so many people are working from home trying to use Teams. I don't know if you've had any experience with when people get audio and video delays in Teams. Does that typically correlate with a network connectivity issue? Or is there so many other variables in play with the whole Teams service that it's sort of like 50-50, or it typically is something else? I don't know if you had any experiences to share there.
I guess it can be caused by a network, but that's not the only thing that can cause that kind of thing, right? You do see issues on clients, just if the machine is overloaded in some way and is starved of some resource. You can see that as well. But we can test quite a number of those potential issues from in the testing tool. One challenge with doing that is that oftentimes what you're looking at is congestion on the network, which is going to cause your delay. Congestion or packet loss means something else is going on somewhere on the network that you're probably unaware of because you can't see these things. and it's causing a delay in packets going out. There's a whole variety of reasons why that might happen. It's often very transitory or time dependent. Are there other people using the same network circuit that I happen to be using? Sometimes they're in your house. You're doing it from home. You can run around the house and find them. Sometimes they're in your neighborhood. Like I look out the window and go, like, who's using the internet around here? But like other times it could be just like 10 miles away in some network provider that happens to be between your ISP and Microsoft's network. And it will happen now. It doesn't happen later. You can, if you run our test tool, we run a short test call, and we measure the network characteristics. We look at various UDP characteristics, which we like to use for these calls. So we can tell you that. We don't today run it like on a continuous basis. You'd really want to run these tests over and over again, see if it got worse at certain times of the day. And the other thing you want to do is try and isolate like what is causing that. It's very, very difficult to do. And tends to be the reason why a lot of us do a lot of network troubleshooting and trying to figure that out. You often hear people talk about, well, if I ever have any networking problems, I go and reboot my Wi-Fi router, and then it goes away. Well, rebooting your Wi-Fi router probably took you 10 minutes. And whatever the problem was has probably subsided wherever it was. Maybe it's your Wi-Fi router, maybe it's something else. But there's a lot more reasons why these things can occur. Jeff, I know you've had your share of these kinds of discussions with customers. Do you want to share anything as well?
Yeah, I mean, I think the only thing that I'd probably add there is that, to Paul's point, that it can be connectivity, it can be a bunch of other things. I just spent a couple minutes a few moments ago talking about how great this single tool is. I think it is still important to understand that Teams has a wonderful thing called the call quality dashboard that allows a tenant admin to go correlate device types that are in use, driver versions, operating systems, various hardware components. All those things can make a fairly significant difference in call quality. And so if it is a problem that doesn't appear to be correlated with network issues, that tooling is certainly available as well. But yeah, I mean, in general, from a network perspective, these do tend to be hard to pin down, it's definitely keeps the network admins in business, right?
Yeah. I'll just remind our viewers too. You just reminded me, in the Teams client, not a lot of people know you can do a test call, and
yes.
It's actually a surprisingly simple tool right before you have a meeting. So
yeah, and I'll even add on to that. So when you finish your Teams calls and you get that little pop-up that asks you what you thought of that call, that's actually a very important metric that we use internally to help correlate network call quality data that's flowing in through that same pipeline that goes to the call quality dashboard, as well as a tool that I work on to help us gain insight into kind of where that dividing line is. Essentially, how much latency is acceptable to our user base, how much jitter is acceptable. That little set of 5 stars, extremely important for that, and we're constantly evaluating what those results look like.
Sorry, I got to interrupt there too, because you just hit a chord there. I did a lot of work in Skype deployments looking at the rate my call data on-prem deployments, and we sliced and diced the data a number of different ways, and at the end result, because what we were looking for is a pattern in how people rated calls with actual call quality metrics in the CDR and Skype. And to be honest, we couldn't find any. It was like we had people rating calls poor that were scored great in terms of the CDR, and then the opposite, we had calls that were just should have been marked poor, like everything was off the charts, and people just said it was good. So it's like we threw our hands up and kind of just said, oh well, there's no correlation here. But that's interesting that you look at that. So obviously, have you found any patterns? Like, what are you seeing?
It is possible. I think once your data size is a little bit bigger, once you start looking beyond a single tenant,
yeah,
things tend to change in terms of ability to draw conclusions. So we absolutely can use that data to make predictions.
Awesome.
Yeah. I think that goes to like user education, right? So if you're rolling out this tool, communicating how important that rate by call is, instead of people just clicking to get rid of the screen, they'll click anywhere, right? So If you communicate that the team is monitoring that, not only their internal IT teams, but Microsoft as a whole is monitoring, which I didn't know, then I think that drives a little bit more value and a little bit more accuracy maybe coming from the end user.
Yeah, if you rate this call as a 5 and you just had a really bad experience, you just said that experience is perfectly acceptable to me.
Yeah.
And that's there's an outcome from that, right?
Yeah, no problem, nothing to fix, right? But Paul, you were mentioning that earlier that, that the connectivity.office.com was kind of the first tool, and you alluded to there's a second tool, and you kind of hinted that, the connectivity site was a one-time test. It's, you probably want more of a continuous method. And I know that a few Ignites ago, there was mention that maybe some of those network tests would be rolled up into the sync client. Maybe if you can mention of like where that has progressed from that announcement a few years ago, and what integrations are we having with the connectivity tools within the Office suite?
Yeah, I'd love to, absolutely. So what we want to do is show these results across the tenant. And so if you're involved in the networking for a particular customer, you can go and see the summaries of where you need to look, what's going on with the network, and dive in from there, and not have to go out to every user location and run a standalone test tool and gather results and do all of that. And so we've been working to take the same tests that are in the connectivity.office.com tool and put them in Office clients. And so they are in the OneDrive for Business Sync client today, and they run periodically, but not more than once a day on a user's machine who is signed in with the sync client. And the test results are aggregated for the customer, and then you can go and see those in the M365 Admin Center. And so they're always aggregated. They don't include the device ID or the user ID. They are rolled up. They are rolled up to the office location where the user is, or the city if this is a remote worker who's not in an office. And so we need to identify the office in order to be able to do that. There's two different ways that we do that. The reason there's two is we found from surveys that about half of our large customers are happy to turn on Windows location services so that we can just capture the latitude, longitude of the device when it's running these tests. We approximate those and we still aggregate them up to the city, so we don't record the user's accurate location. But about half of customers that we work with don't want to do that. They don't want to turn on location services. And so instead, they can actually add, or you can import a CSV file of locations, and you can specify what's known as the LAN subnet for each office location. And so we can correlate the LAN subnet that you've entered with the address that you've entered, and all of the test results that come back from that LAN subnet will be shown aggregated for that address. So there's two ways that you can get that location. Once you have that, we can show the list of locations that you have offices at, and we can show the network tests for each of those locations, which of course is what you want, because you're trying to identify the network connectivity from a user location through their network perimeter out onto the internet, wherever that location happens to be. And these are different for each of your offices, every city, every country that you have users in. And then we can show the network assessment for every office location and particular insights where tests are above thresholds. Now, this is not a single test, so you can't go and run it and then see the result right away. You configure it, and then machines that are running OneDrive will share the network test results, and those are aggregated overnight into the admin center. And so you can go in and take a look at them after that. And so we're able to do things like we show a map of where all your office locations are, and you can see color-coded network performance from those office locations on that map and drill into where there maybe are ones that are not doing so great. But this is essentially an end user version of the connectivity.office.com, where connectivity.office.com, yeah, you got to download some things. But if you're a network admin at a particular site and you're trying to drill into something, maybe that's what you want. Because that's a standalone application, we can actually rev it faster as well. we're pretty aware that most end users, more network engineers than end users run it, and so we try to add tests in that first and then get feedback on that. Whereas if we put a test in Outlook or the OneDrive for Business Sync client, that test has got to be unnoticeable by the user. It can't have any impact on their resources, can't take their network down or do anything. So we have to be really careful and pretty slow at making those changes and getting those in there. We also don't run as many tests in those clients, primarily ones that are necessary for showing these insights, where we run tests that people look at in connectivity.office.com if they're trying to do some troubleshooting, and they can come and go. So there's different uses for the different test tools, but the end goal is to be able to show a large customer how are their users doing, what can they improve in their network connectivity, their network perimeter, particular devices which may or may not be helping or hindering network performance as seen by Office 365 users, and that sort of thing.
And just for our viewers, where would they find where to configure that and see the results of these network tests?
Yeah, so it's set up in the M365 Admin Center, and we have a page under the Health tab called Network Connectivity. This is shown if you are either an Exchange admin, a SharePoint admin, or a Teams admin, or a I think it's called System
Global admin.
A global admin will see it as well. Yeah, there's one other that you can add, but so a number of the admins will see it. I think there's a report reader role that you can be in, and that you can see it, but you can't configure it. But it's all there. Today, it's actually in public preview, where at time right now, while you guys are publishing this, we're I think a couple of months away from being a generally available release that's supported. So as a public preview, the first time you go into it for your tenant, you're asked if you want to join the public preview. You can actually click straight through and immediately see data that we have and start to configure it and work with it. But that's where it is at today.
I think it's pretty amazing that, in enabling or empowering the network engineer to see what's going on for all their endpoints, regardless if it's at home or in the office. So I think it's pretty powerful too, and I can't wait to see the evolution of that. Is there any timelines on the tests coming into other clients other than the OneDrive Sync client, or is that further down the road?
We're still working on those, and there's still more tests that we want to add. One area that we've been working on, like for the last year, is tests specific to home users, and so you'll start to see those tests are in connectivity.office.com. We are looking at VPN configuration, and there's some particular Office 365 guidance about getting good connectivity for Office clients through VPNs and splitting out. So we've been adding that and adding some other things to support home users in there. So there's a lot more to do, yeah. And also coming to those other clients, we need to get that done as well. But all of the tests are run in the OneDrive for Business Sync client. Like, we do run tests supporting Exchange. We run test calls for Teams. So that suits the example if you've deployed OneDrive today but haven't deployed Teams, for example. But we want to get into those other clients. So whatever client customer has deployed, those tests testing their network will be there and be able to show them where they're at and what they could do to improve.
It's definitely excellent. Any tool to help troubleshoot calls and getting that experience kind of top notch for the users is amazing. Maybe because I have you two on the call, maybe I'm going to throw this out here. Is something that's coming up quite a bit with our team's customer base is really the guidance around ExpressRoute and Office services, Office 365 services like Teams, and maybe how that shift to that kind of maybe recommendations around ExpressRoute, how that's kind of landing, and what you guys kind of recommend to your customers.
Sure, I can jump in. Yeah, so Microsoft changed our guidance for Office 365 or Microsoft 365 customers a few years ago, where initially, when we initially launched support for ExpressRoute for our workloads, it was talked about as potentially a good option that just kind of made generic sense. If you're going to deploy ExpressRoute, this is a great use case for it. And I think we learned very quickly that wasn't necessarily the case. And the reasoning really comes down to kind of jumping back to those principles of network connectivity that I mentioned earlier. The very best way to have a great experience with Office workloads, regardless of which workload we're talking about, and this absolutely includes Teams, is to look at local direct egress of network traffic, where you're not carrying that traffic across a large distance, and essentially doing some sort of like composite egress, where you have multiple branch locations carrying all their traffic to a data center, and then from that data center, sending that traffic to Microsoft. That adds latency and potentially congestion. You potentially run into bandwidth issues in doing that. What we find is that the very best way to ensure great connectivity is just getting that traffic out on the internet as close as possible to the end user, and letting the internet do its job, letting your ISPs do their job, and getting that traffic to Microsoft then as quickly as possible. And ExpressRoute kind of deviates from that. Well, it doesn't kind of, deviates from it fairly significantly, and it really encourages customers to move towards that pattern of backhauling that traffic across a wide area network, sending it out in a minimal number of locations, and adding latency as a result. And frankly, it adds a lot of complexity to network design. And coming from a role where part of my team's job was helping large enterprises implement ExpressRoute, it's very difficult to do it right. Very difficult. It takes a lot of energy, a lot of expertise to really get a solid ExpressRoute implementation that's going to be always available and provide high performance. So we really recommend that customers head the internet path. There are options certainly to gain some of the perceived benefits of ExpressRoute. Microsoft does have something called Microsoft Peering Services, which is sort of an advanced form of internet connectivity that gives you some additional insight into the quality of that connectivity in cooperation with your ISP. And there's certainly ways where you can leverage multiple ISP connections from each of your branch locations. Just go to your cable company, get a circuit from them, go to your telco that's providing fiber as a commodity, get a circuit from them, and deploy some SD-WAN hardware, and allow that SD-WAN hardware to make the best choice. You end up with some fairly significant performance and availability advantages, probably at a lower cost than you would heading down the ExpressRoute path.
Well, thank you.
Yep.
No, that's great. I mean, I have some customers that are using ExpressRoute, and they're essentially doing exactly what you're saying, but they're using the ExpressRoute primarily for all of their Azure services and VMs and everything like that they use from connectivity from an internal perspective, which makes a lot of sense, right? So just, I want to talk a little bit more on that, given that, everybody's working from home. I've seen a lot of organizations that, we've been lighting up on Teams, initially completely against VPN split tunneling because, they want to be able to control and see, all the traffic coming through. And surprisingly moved into a split tunnel model as well, right? Once they saw that performance hit, like you said, backhauling everything into their network and then sending it out as well. There still are some organizations that are still against the split tunneling. So maybe, again, with sort of like a recommendation, what would you think, Jeff, with regards to the recommendation for the split tunneling for the services to access this?
Yeah, we absolutely see similar interest from customers, similar questions, and frankly, when the COVID lockdown really started to hit around the world in March and April of last year, this became a super critical question for really all of our customers. And we spent quite a bit of time putting together some split tunnel VPN guidance, which you can find on the Microsoft Docs page, that describes both our best practices for split tunnel VPN, as well as points to implementation guidance. We actually reached out to the major players in that space to help kind of combine their documentation and their guidance with our best practices and put together some kind of template deployment guidance for each one of those solutions. The way to think about it is that we fully understand that not all Microsoft 365 traffic is the same, and customers are going to have significant qualms about split tunneling or direct egress, local escape, whatever you want to call it, of all of the Microsoft 365 traffic. There is traffic included there that Microsoft doesn't control, right? We use a lot of third-party content distribution networks. There are integrations with non-Microsoft products all over our products, and that involves connectivity to these third-party services. So Microsoft can't make any claims about those endpoints and the way they're managed and the security. And therefore, we wouldn't want to go in front of a customer and say, you should absolutely take all of that traffic, bypass your security infrastructure, and send it out directly over the internet. That's not a position we want to be in. So what we've done, and this goes back again to those principles of network connectivity, is come up with categories of traffic. And there's three categories: optimize, allow, and default. The optimized category is the category that represents the most latency sensitive and bandwidth intensive traffic associated with our productivity cloud. And when you think about doing split tunnel VPN, that is the set of traffic that you want to be able to split out of the tunnel and get to Microsoft as quickly as possible. We make representations in our documentation about the fact that all of those endpoints actually exist in Microsoft data centers. All the material that you can find in our trust documentation applies in terms of how those are managed, who has access, all that stuff. And so that then gives you some flexibility with the other categories to potentially, continue to send that down the tunnel, perform whatever monitoring or inspection you want to do on that, and get that extra visibility and control.
No, that's great. And then I just have one question that's you kind of talked a little bit about that before, and we talked offline a little bit as well, and I think it's really, really cool. You talked about this new functionality called informed network routing. Maybe tell us a little bit about that and what it can provide.
Sure. So yeah, I kind of alluded to the concept of customers using SD-WAN solutions, software-defined networking, software-defined wide area networking solutions to connect their branch locations and take advantage of potentially, commodity internet circuits to carry their internal traffic, as well as provide some ability to differentiate different application traffic and treat it based on business requirements and security policies. We're seeing a lot of interest amongst customers in beginning to implement SD-WANs. And one of the key reasons for implementing an SD-WAN is around application experience. You want to be able, as a network administrator or an IT pro who's managing that infrastructure, to be able to make assertions to your user base about the fact that Teams is going to have a great experience, regardless of what how that traffic is going to get to Microsoft. You want to be able to control that path, and you want to be able to gain insight into how it's performing over time. So the SD-WAN vendors, SD-WAN partners, I should say, also, certainly see that this desire for application insights is, a key factor here, and we're taking advantage of that in many ways to kind of take what Paul described about understanding where users connect from even a step further, where with these partnerships that we're building with SD-WAN providers or SD-WAN partners, we're providing the ability for our customers to actually get very deep application insights directly from the applications themselves, not synthetic transactions that are running to generate some of the data that Paul was referring to earlier, but actually the activity that's associated with Outlook or Teams or SharePoint running against Microsoft Service endpoints in near real time, specific to each branch location and connectivity circuit that's carrying that traffic. That information can then be passed back to the SD-WAN solution, where it can be used for a couple of really cool purposes. One of them being actually displaying that information to the network administrator, so they can see that, at this location at this time, Outlook is doing great, and Teams is doing great now. Maybe had a little blip 10 minutes ago, and that was due to my my connection that's associated with ISP-A, and my SharePoint connectivity happens to be running over my connection to ISP-B, and it's working. It's been working just fine. You can get that level of visibility. The other thing that it can be used for is making better routing decisions, and that goes back to the name of the feature. And so when we start running into these problems with, hang on a second, I'm getting interrupted by a kid.
Our guest star.
Yeah.
That's our guest star. So when we're carrying this traffic, across, and we have a choice about multiple network circuits that we're gonna use to get the traffic to Microsoft. We can then use this set of metrics that are coming down, both in terms of the real time. One sec, buddy. Okay, got it. One sec. We can use this to make a choice about the best possible path, and we can also use it in a similar way to what Paul is doing with the admin center, where we can compare the actual experience of other customers in that area and make an assertion about whether or not the performance of that given circuit is actually, realistic or appropriate for that area at that point in time. So it also is in public preview. We launched it with Cisco as our launch partner. And it's available in the current version of Cisco's iOS XE SD-WAN platform for Exchange only. Teams and SharePoint support's coming soon, and we've already started conversations with a number of other SD-WAN partners. So looking forward to more partnership announcements there in the future.
Oh, that's awesome. It's really exciting stuff. I think that you guys are both working on that, going to provide that level of information to, Microsoft's customers, and three out of the four of us are consultants, so I mean it definitely helped us as well. And I think from a development perspective, where Curtis works in as well, I think that would help as well. So definitely appreciate you guys coming on and giving us your insight and experience and recommendations, really, for our viewers and listeners. Again, thanks for coming on. Thanks everybody for listening in. Hope you enjoyed the episode, and hopefully we'll catch you on our next episode.
Thanks, guys.
Thanks.
Thanks.